right.
First lifted.
Okay, so let's talk about the lab that we started yesterday, which we will finish up today. And then tomorrow, we're going to start to introduce KSP and QSP. Your third and final quiz before the really, really big test of acid-base equilibrium is going to be on Thursday, okay? So, what?
When will that big test be possibly? Those are born.
And it's gonna get wonky with parent-teacher conferences, so I haven't had that vision yet, because parent-teacher conferences are just a train wreck.
It comes to you in a dream, it's just like, oh, now. Set it for a week. You said you haven't had that vision yet.
He's a prophet.
It's just like,
I haven't hit the peyote yet. So.
wakes up in the middle of the night, it must be March 1st.
When should I order my chem?
Beware the Ides of March.
He has a revelation.
Face
The
paint.
Oracle
Next
speaks to
Wednesday.
whether they're ready or not.
Day after tomorrow.
Here we go.
Now.
There will come
Okay.
a test so big, so bad, my children will fail.
I'll walk down with like carrying stone tablets.
Oh my god.
I have a revelation.
Thou shalt not covet thy neighbor's acid. Okay. All right. So anyway, so back to our story. So you're not going to have to write out the names and formulas of any of the strong acids. But what you are going to have to be able to do is if I give you like a list of like lithium hydroxide or sodium acetate or something like that, be able to recognize it. Is it a strong acid? Is it a strong base? Is it a weak acid? Is it a weak base? Okay? So that's what you got to be able to do. Heavy on calculations, okay? Like I'm going to give you like, hey, here's a weak acid. You're going to add a certain amount of base to it. What's the pH after this? What's the pH after that? I promise you, you're going to reach a point where you're going to have an anion and a weak acid that's completely neutralized, and you have to do that secondary reaction where you go through, find the new molarity, find the Kb, find the hydroxide, find the POH, subtract that. Promise you that's going to be there. Okay, promise you. There's going to be buffered solutions on there. Okay, so understand to be able to recognize buffered solutions. So that's going to be on Thursday. Okay, so just fair warning, 2 days out. I had that revelation this morning, so Thursday sounds like a good day to give them a quiz. Let's do that. Okay.
This is not a good day.
Oh, anyway. So let's talk about what happened yesterday. So you just had a straight acetic acid, H3O2, and then you added just
You were going to say something too, don't
sodium hydroxide, okay? Now, here's what you should be able to do. You don't have to do this, but this is what you should be able to do. Is that when you draw that curve and you generate that, you should be able to take a curve like that and determine the equivalence point, half the equivalence point, the pKa, and the Ka, okay? So that's flashbacks to that first lab that you all did. So I'm not asking you to do that, but you should be able to look at that. It only works with the first curve because that's the only one that's a non-buffered solution. So if I gave you a curve like that, which I'm going to at some point, be able to calculate the equivalence point, half the equivalence point, the pH at the half the equivalence point, the pKa, which is the same thing, and then the Ka value. Promise you, at some point, depending on when I have the vision, that's something you've got to be able to do. Promise you. Okay, so here's the second titration. You're going to add a tiny bit of sodium acetate to it. So as soon as you add that sodium acetate, what have you changed it into? A buffered solution, okay? So what you want to do on calculation number 1 down below, you should be able to calculate the theoretical starting pH of that solution. It would make a really, really good non-weighted GPA, okay? A a really, really good non-weighted GPA.
Say, ask if it's perfect.
Like,
Perfect,
like,
perfect.
I'm just saying, you take that however you like.
well, really good by my standards would be like 2.
Stop it. Now, on calculation 2, here's what's going to change. What you're going to do is I'm going to say, hey, I want you to prepare a solution that's going to start with a pH of 6. Now, here's the grand idea. If you look at pH equaling pKa plus the log of your anion concentration divided by the concentration of your acid, start with this. Now, the pKa of acetic acid is 4.74, okay? That's like the root structure. You can't do anything to alter that. But just think this through. You want to end up with a pH of 6. So what do you know about the anion concentration relative to the concentration of the acid?
But the anion has to be bigger than the acid.
Anion has to be bigger. Why?
Because it's greater than the pKa.
Because I've got to add a number to get to 6. Okay? So I've got to take the log of a number bigger than 1. Okay? So, when you get done with that calculation 2, check with me, because there's no point in doing that titration if your mass of sodium acetate is wrong. Okay? So when you get that second calculation done, ask me, and I will tell you if it's right or wrong. Because if it's wrong, it's just going to be a train wreck. Okay? So when you get done, you should have 3 different titration curves. One that's going to start pretty low, and then you're going to have another one like that, and then you're going to have another one that's going to start at 6. So you're going to have 3 different titration curves. Somehow color code them, do something, have a key so that I can look and see, hey, this is what's going on, okay? Just don't randomly draw 3 lines and go, oh, Burkamp will know what's going on. No, Burkamp won't know what's going on. Now, here's another part of the lab that you actually need to do today. So when you look at the, what's the other sheet? Blue sheet?
Blue.
Blue sheet. Blue sheet. Blue 22. Blue 22. Okay. So down here on the page that says late night with a dreaded chemistry teacher, you have questions 9 and 10. So what you have to do here is calculate how many grams of ammonium chloride are required to produce 25 milliliters of a 0.2 molar solution. So do that calculation, get a number. And then you're going to do the same thing with how many grams of sodium acetate would be required to produce 25 milliliters of a 0.2 molar solution. Okay? So here's what you're going to do. Then on questions 11 and 12, what you're going to do is you're going to take a clean 100 milliliter beaker. You're going to take your volumetric pipette, and you're going to get 25 milliliters of water, to which you are going to add that mass. And then you're going to have the initial pH, and then you're going to look at what's going to happen after you add the ammonium chloride or the sodium acetate. Now, sometimes our water gets a little bit wonky, okay, in terms of pH, and we really don't know why, but sometimes it gets wonky. So what should happen, okay, make note of this, on 11 and 12 when you do these observations. Question number 11, you're going to have your initial pH, probably around 6 or 7. When you're going to add that ammonium chloride to it, what's supposed to happen, and again, sometimes our pH gets a little bit wonky, is the pH is supposed to drop when you add that ammonium chloride to it, because the ammonium is NH4, it gives up a hydronium ion to the water, you increase the concentration of your hydronium ions, and it goes down, okay? About 90% of the time it goes like it should, but for about 10% of the time, the pH is so far, it doesn't work like it's supposed to. Now, what's supposed to happen on number 12 is that because you're adding sodium acetate and you're reforming the acid and hydroxide ions, that pH should go up, okay? So Hopefully it does, like I said, about 90% of the time it goes like it should, but about 10% of the time it doesn't, okay? So on number 11, make a note. What you should see is the pH should go down. On 12, what you should see is the pH goes up, okay? All right, so this is due tomorrow, okay? Not Thursday, okay? It's due tomorrow, okay? I want everybody to hear this. Well, for those of you that aren't here or watching on the television, but it is due tomorrow, right? You have the rest of the time. Get the titrations done. You got 3 graphs to draw and then the sheet of calculations. I'm done. You're on your own. Be free.
Let's go.
So you have to stop you on the camera, please.
I'm gonna get ready.